Awesome. All right. Good morning, everybody. Thank you for coming to another session of our bi-weekly meetups. So, excuse me. Before I go further, I'm going to introduce myself. My name is Aziz. And for those who are new, we've been doing these meetups every 2 Saturdays for, it's going to be, actually, it's going to be 2 years soon in March. So a little more than a year and a half now. And typically we present on the topics are going to be software engineering, LLMs, AI, cloud. Last year we did a lot of data engineering. We haven't done a lot of data engineering, I would say, in the past 6 to 8 months, mostly because LLMs and AI have kind of taken a lot of, I guess, time and energy to present on those subjects. A lot of demand on that. But we kind of wanted to go back and talk about data engineering, and mostly because it's still a very important subject and a very important field, especially, at least for my opinion, especially as folks, put in place AI solutions and and the likes. You would still need data. Will still be needed, right? Data will still be needed. Building pipeline will still be needed. So the point, I guess, of this presentation is twofold. One, go back and do an introduction on what data engineering is, what it entails. And secondly, pick a platform, in this case, Databricks, to kind of do an overview of that. My goal at the end of the presentation is not to make you a Databricks expert. That's not gonna happen. It's more to give you a flavor as to what this platform is about, what it could do in terms of, say you want to get into this field, how it can help you, further your skills. Yeah, so that's my two goals for this presentation. I usually do this presentation with Ben and other folks from the team, from the group have also presented. So if you have any inclination in presenting any topic at all, obviously reach out to us. We'll help you kind of set it up and prep for it. So any questions before I get started? All right. So data engineering. What is data engineering? I'll kind of give you a quick story as to how I got into data engineering, and so my career kind of started as software engineering. I did some software engineering, and funny thing, I actually started it with Ben at a company we worked at together, and I eventually got into data science because that was kind of like my background. So software engineering, like pure coding, writing apps, wasn't necessarily what I wanted to do at that time. So I got the opportunity to get into more data engineering. I'm sorry, data science. And I did that for a little bit, and then I realized that there's actually more work doing data engineering than actually doing data science. And that was probably around 2016, 15, 16. So I started kind of like by accident, started learning some of the data engineering aspect. At that time, it wasn't even called data engineering. It was more like big data development at that time. Oh, yeah, go ahead, Abuba.
So what do you mean that there was more work in data engineering? You mean
Yes.
that more job opportunities? Is that what you mean?
Yes. So maybe I skipped a little bit. So I was doing consulting for a big consulting firm, and by more work, what I mean is that every time you would go on a project, typically projects are maybe 3 months, 4 months, and I was doing data engineering. But then when I would finish the project, to find another project, another data science project, was getting harder and harder. However, I noticed that the project where it entails more data engineering as opposed to data science. There were a lot of them, a lot of projects about you know do data processing, things like that. So that's why I was like, maybe there's something to it. So I kind of and when you do data science, you do some data engineering. It's part of it. When you prepare data, for fitting it in models, that is in a way that's some parts of data engineering, right? So that's why. So it was more like I noticed that I was not getting a lot of projects in data science, but more projects in data engineering. That's why I said there was more work.
So that means that you have to go back to college? Is
No,
that
no, no, no. No, no, not at all. The skills that I had to do data science, right? Those skills were transferable into data engineering. And remember, I also had some experience, doing software engineering, right? So it was just a matter of like me putting myself into position of, learning new tools. At that time, it was tools like Cloudera, for example, or which is a platform that dealt with big data, and it had tools to do data processing. So it was kind of like really jumping in and learning on the fly, if that makes sense. Yeah, and
so
no.
you learn on the job basically?
Mhm, mhm, yeah,
Okay.
but I had a little bit of experience on some aspects of it also.
Yes.
It wasn't like it was from scratch. No, it wasn't from scratch.
Okay.
Yeah. Any other questions?
Uh, Maybe I didn't hear, but what's the difference between data science and data engineering?
Yeah. So data science. So you can think of it this way: data science, right? You are basically a data scientist. You're basically um, modeling. You're building models to predict some things, right? And as a data scientist, some of the skills you need to have are going to be like, a lot of statistics, a lot of probability, right? And knowing models, how to get the data ready, how to use the data to build model and then interpret those models and then provide recommendations, right? So that's the data scientist. But in order to do machine learning, in order to build those models, you need data, right? The data needs to be in a certain format. So it needs to be processed, right? And that data processing, some data scientists rely heavily on data engineering to get that data ready for them, because you can't just take the data like that as is. And usually the word that they use is called raw data. You can't just pick raw data and fit it in the model. No, it just won't work. It needs to be processed and be in a certain way for it to be fit in the model. So a data scientist can do some aspect of data engineering, but most of the time that is left to a data engineer. So the data engineer is the one who's gonna build pipelines, for example. So they may need to get the data, let's say from Google, and put it in an environment in the cloud, and then they're gonna sit with the data scientists and be like, okay, how do you want your data to be? And the data scientist will say, hey, I want these columns, this column, this column, and I want these calculations, this calculation. And then you as a data engineer are gonna use SQL most of the time, or Python or Spark to manipulate that data and have it be in a certain format, and then the data scientist can now use it. So you see, there's a little bit of a difference there. I don't know if that helps.
So yeah, it makes total sense.
Yeah.
I have a quick question though.
Uh-huh.
I'm just curious. When you say models, the data
Mhm.
science, it has to create models. Can you give me an example of models?
Yeah. So if I remember correctly, like, so XGBoost was a model back in the day that people used. So let me see if I can create. So for example, XGBoost. So XGBoost, for example, is a machine learning library. Well, that's actually a library, right? But you use it to basically build a model. So you can think of the model as, for example, let's say you want to build a model that can deny or approve like a insurance claim, right?
Okay.
Yeah, so basically these two cases, so deny or approve an insurance claim, right? So in order for that model, to be able to do that, it needs to look at previous insurance denials and insurance claims, right? Denials and approval of insurance claims. So it knows what it takes to approve a claim, what it takes to deny a claim, right? So that when you give it a new file or a new client, then it can look at it and be like, oh, okay, based on what I know from previous claims, this new claim fits a denial, and then it would deny the claim. So the model is like that decision making, for the lack of a better word, tool that you could use. And that's just one example of model. There's a lot of different ways of building models or different models, but that's kind of like one way.
But so it looks like he involved, I would say, machine learning, right? Because you have to that could train the model, basically. Okay.
Yep.
Wow.
Yep.
Okay.
Yeah, machine learning is part of all that. Yeah, it's part of it. Yeah, that's like the how do I say that? Yeah, it's kind of like the actual work, yeah, machine. So there's a lot of like cross between data scientist, machine learning engineer, all these things, right?
Yes.
Yeah.
Okay. Thank you.
Yes. So going back to any other questions before I continue? All right. So going back to the data engineering, right? So the aspects of data engineering that I think as I would say very important is the ability to build pipelines, right? So because the pipelines are important because that helps you put in place systems that would automatically serve the data to anybody who needs it, right? Because you got to remember that data, depending on which organization you work for or how you are, you may need to get data from someone else or another company, and then add that to the data that you have, which is called kind of like enriching the data, and then at the end do something with that data, right? So basically that is kind of like, you can think of it as like building a pipeline. Data warehousing is kind of like where you might have you might store your different types of data or different type of your structured data. So and then you have database tools or database software that you call data warehouse, right? For some reason, I'm blanking on an example of a data warehouse right now. So, maybe like BigQuery is an example of a data warehouse. That's a Google solution for data warehousing. And data lakes is kind of like back in the day of like big data. Data lakes was really big. So you can think of it as like a place where you store all your different types of data, whether it's structured, semi-structured, unstructured. So basically the difference between structured and unstructured. Structured, you can think of it as like, when you have data in your Excel and you have, let's say, like customer information, right? Like name, first name, last name, date of birth, salary, and among other things. So you can think of it as like nicely structured, right? It follows a certain pattern and it's good to go. Unstructured, you can think of it as like pretty much, everything else. So things like text, videos, audio, you name it. So it doesn't necessarily follow a particular structure. An example would be like, let's say you go and make a comment in Amazon. Your comments, the way you put it in there, like the number of words will be different than someone else, for example. So yeah, and semi-structure is kind of like in between. One of the key aspect or key feature, or with lack of a better word, step of data engineering is the process called ETL, which is kind of like extract, transform, load. And I think I kind of touched a little bit on that. Let me make this picture a little bigger here so you can see. I think it would be this one. Nope, not copied, not that, not this. Okay, so extract, transform, and load is basically kind of like these steps right here, right? So on the left side, your data source, right? Where are you getting the data? So I'll take an example of a company like, let's say like an insurance company. I'll go back to the insurance company again, right? So the insurance company will have sometimes their own data, so like their own customer data, right? For example, things like, how much they pay for their premiums, their age, salary, and the type of insurance they have, right? For simplicity. Now, in order to, let's say, figure out how this customer is going to fit into the, let's say, model of insurance, they may need to get more information about that client, or they may need to get more information about a particular group of clients. Let's say they group this client in like high income earner, for example, right? So the insurance company may be like, oh, so we need data from another place, to enrich the data that we have. So they may get data from the census, for example. It's the Census Bureau. They may get data from them. So in that way, one way would be to pull via, things like APIs, which are application programming interface, and get that data into their system, which is the ingestion part, in their system, right? So that's kind of like, the data ingestion step. Another example would be how you get data from sensors, right? For example, an airline, like a plane, right? A plane is flying, the engines up, creating data like at milliseconds, like engine temperature, like coolant pressure, among other things. Then that information is sent back either to the manufacturer, like let's say Boeing, or the airline operation area, right? Because they need to monitor, all the engines that are running right now, see if anything is out of sync, for example. So that would be like an IoT device. Like an airline engine would be kind of like an Internet of Things IoT device, and then it's ingested in some sort of data warehouse or some sort of data lake. So that's kind of like one step, right? Then you have, when that data land in what you might call like some sort of like a raw zone, you could basically do as a second step, extracting it from, let's say, like a raw area into another place, right? It could be like a processing just as a step for your company. It doesn't necessarily have to be that way, but it could be just one step. Then transformation is the second step, or another step in that pipeline, in that workflow. The transformation is maybe taking maybe joining the, if we go back to the insurance example, maybe joining that client information with something else from that new data that you put into the system, into your system, right? So this is where you start doing transformation of your data, joining tables, doing some calculations, for example, maybe calculating average age of someone defaulting on a claim, for example. This is where you do a lot of your logic, right, and your transformation. And then when you're done with that data, the transformed data, or needs to go somewhere, right? And that step is kind of like the loading step. And, you load that now into some other storage area. It could be another data warehouse, could be, somewhere else. And when that data is, for the lack of a better word, cleaned, then this is where your data scientist can come in now, right? So on the right side here, you have BI intelligence, right? And reporting and analytics. This thing is kind of in the way there, but this is data science. in the back here. So this is where the people consuming that data that's cleaned up or transformed can now use it. So that's kind of like the pipeline from here to here is what a data engineer would basically build. Any questions? All right. So data engineering.
Quick question, if you don't mind.
Go ahead.
You mentioned something about the data lake,
and
you said back in the days, like they were obsolete.
So that's a good question. So by data lakes are not technically. So the reason why I say back in the day is back in the day of like big data, the whole like big data era. So that would be like 2012, maybe a little earlier than that. So at that time, I don't know if you remember, there was, some of the job postings were, we're looking for a big data developer or, something like that. These days, you may not see that title as much. It would mostly be called data engineers these days. But that's why I say data lake, because at that time, a lot of when companies, okay, let me even step back a little. When companies were starting their journey into getting more into big data, you got to remember that where the data was located, so where they had the data, it was mostly in databases. So it was kind of locked into some, either Microsoft Access, or SQL servers, or in some file somewhere. It was all into databases, right? It was kind of like siloed and locked in. One of the first steps to kind of like get into more of the big data and the whole thing about big data processing and machine learning and all that stuff, you have to get that data out of those silos, right? And put somewhere where it can be processed or it could be used, or you can start that journey of processing it. And at that time, data lake were the place where they would land that data. So let me go back and kind of look for better definitions. So in Hadoop, not Delta data lake. See, that doesn't even show up anymore. Let's see. So yeah, so it was a place where you basically a centralized place where you store your data, right? So back in the day of, like, let's say Hadoop and the big data world, Hadoop was really popular, and one of the where you would basically land that data was HDFS, which is the Hadoop distributed file system, and that's where you basically dump everything you can from your company, those CSV files, those sales files, those customer files, all will go into a data lake basically, and then from there the company can now basically do whatever they need with it. Yeah. So does that help?
Well, yeah, absolutely.
Yeah.
Thanks.
And the reason again, one second, Ben. The reason again why I say back in the day is because the word data lake is not used as much anymore, right? So you have like terms now like lake house, which I don't even know what it means right now, or Delta Lake, which we'll talk about with Databricks. Go ahead, Ben. Ben, you have a question?
Oh, it's more like just like a small comment. So Brunel, to answer your question again, it's almost like there's a lot of processes that companies adopt. Like doing big data is one of them. There's actually more, but depending on where the whole industry thinks that a competitive advantage can be gained, that's where the hype will go. You know what I mean? Like today, sorry about that. Today, people are focused on machine learning and AI, not because companies were not doing it for a while. It's just that right now, this is where the competitive advantage is. So all the buzzwords and the hype will revolve around that at the moment. So,
Yep.
Yeah. Okay. Yeah, I get it now.
Yeah. So it doesn't mean that it's not like the people don't have data lakes anymore. No, it's just that it's just not talked about as much anymore. And Ben, you and I actually had a conversation about that just on Ubuntu Cafe 2 weeks ago, if I'm not mistaken. We talked about that actually. Anyways, all right. So quickly,
Aziz,
yeah.
That's the question.
I see a question in the chat.
Oh, let me look.
You want me to read that?
The fact and dimension part of data science. So the designing a fact and dimension model part of data science. I wouldn't necessarily say it is part of data science. I feel this is more for someone who knows well databases. So it would probably be for an architect, database architect, because that is you're dealing with more of the how do I say that? The data, to get the data ready for the data scientist, right? So as a data scientist, I see more that role being really the data is ready or semi-ready, and you basically take it, you find which model or which library to use to to build a model, and then you go present that case or present your case to the managers or the higher ups. And then when the model is put in production, you basically monitor and see how the model is doing, things like that. Yeah. Designing a fact and dimension model is mostly going to be for a database architect or someone who's really good with databases. Yeah.
Okay. Thank you.
Yep. All right. So the skills, I would say, and Akuba, I think that would help you here. The skills, I would say, to be a data engineer, 100%, I would say one would be SQL. And that goes back to a discussion that Ben and I had about learning, one, the basics, but also two, knowing the word that we use. I can't remember the words that we use. But basically, it's making sure that when you learn something, one, you learn the basics, but your standards, I think that's the word, standards, right? And SQL is a standard, like for all the databases that you would probably use you're gonna be able to use SQL to do analysis, query the database, even doing processing of the data. One way or another, you could use some way SQL, even though it's maybe wrapped into something else. SQL is definitely important. And last year, I actually went through a SQL training. We might actually do one again, maybe sometime this year. But SQL would be your number one friend if you want to get into data engineering. Knowing databases. So databases like MySQL and also NoSQL databases would be important. These days, cloud is becoming or is huge. So knowing cloud would definitely be helpful. I would not go straight into be like, oh, let me learn cloud to become a data engineer. If I were me, I would go, first of all, go SQL, understand databases, how to build databases. By build, I don't mean like, I mean like maybe creating an instance and then loading data, querying the data, playing with the data there. Python is also very helpful. And knowing data warehouses, ETL, and as I said, even knowing things like dimension table, fact tables, and yeah. So for sure, SQL, I would start with that, and that's a standard across. I think Python is becoming a standard as well across. So yeah. I don't know, Ben, if you have any other advice on this part, but yeah, I think to me that is the one thing that I would say would be important.
Yeah, so for the SQL engine to run, two pretty good ones are Postgres and also SQLite. I mean, they are not specific to data engineering, I don't think, but they are very widely used for many different use cases.
Yep. And SQL is not, for those who may not know SQL, it honestly it is not, as for beginner, it's not that, it's very intuitive. And the reason why it has stood the time is because it's used by a lot of like to do analysis, and it's very intuitive to start with. It can definitely be very complex when you start getting into logic and business logic and things like that. But to start with, it's pretty approachable. And I highly doubt you would go to a data engineering interview where they would not ask you if you know SQL. That's a standard. So now, some of the kind of like specialized tools that data engineers use, obviously Databricks is one of them. I first got introduced with Databricks back when I think it was 2015, when Spark was becoming popular. So Apache Spark is a tool / framework / programming or processing framework that was created by the people who actually created Databricks. And it's widely used to this day to do data processing. Snowflake is another company that is huge. I think it's actually a direct competitor of Databricks. But I have not used Snowflake myself, so I don't really know a whole lot about them. And I don't think Snowflake. Actually, maybe we might do a talk on Snowflake maybe in a couple of months. Give me some chance to kind of look into it. Yeah. Fivetran is kind of like a tool that folks use in to build data pipeline. Matillion is another company as well. All of these are actually companies that folks use to do data engineering. DBT is on. I actually plan on doing a talk on DBT. I would say maybe in about a month or so. It helps with doing data transformation. So, and the last one, Airflow. So Airflow is actually what helps you build the pipelines. So we had our talk on Airflow last year. No, maybe 2 years ago. Actually, either last year or 2 years ago. But it's a very popular tool that is used with a lot of companies. So what it does, it helps you build pipeline, schedule them, and then you monitor those pipelines. So it's heavily used by companies. I put this here. I won't stay too much into it, but the ACID transaction in with databases is kind of like a good concept to know. So ACID transaction, the A stands for atomicity. So basically means the transaction is treated as single and indivisible unit of work. So, for example, when you're transferring money into two bank account, the autonomy makes sure that the operation happens together, right? So as ACID is a feature that databases actually have. So when you say a database has like ACID compliance, or for lack of a better word, that means that database will provide you with atomicity, consistency, isolation, and durability, right? So in terms of consistency, so using the bank account again, so if your bank account goes down below 0, right, and a transaction tries to withdraw money again from your bank account when it's 0, you will notice that it would say, no, you don't have enough money, right? So, but in order to know that, in order for the system to know that, they have to query the database where your information is, right? Where, John Smith's information is, to know that, oh, the balance is below 0, hence we can't give them the money, right? So that is consistency. And no matter which ATM you go to, that would still be the case, because it's pulling from one database that has that consistency. Isolation, for the same example, it makes sure that current transaction does not interfere with each other. So let's say two people are trying to take money from the same account, right? If there is enough money in the account, both transactions are going to happen, right? But one is going to happen first, and then the second will happen after that. But you as the consumer, you won't notice that because it's really fast, right? But both transactions are isolated from each other. And durability is when something happens, when a transaction happens into the database, and then there's a failure. When the system is back online, you go back to that same state where you are. So the database is able to go back to that same state right before the crash, right? So for example, if you transfer money, so after money transfer is completed, the changes in the account are permanently recorded. So even if the bank server crashed immediately after the transaction, the data will be recovered when the system restarts. So when a database offers you that ACID compliance, it's actually really, really good. And a lot of like critical systems like bank systems, systems that need this, you will have it where they will almost all use the same databases, for example. Yeah. So I went through this very quickly because I talked about that later on in the talk, but ACID is something that a lot of if you're working in database, it's something you will know. All right, so now we're getting into Databricks, right? So what actually, before I start, before this talk, has anybody ever heard of Databricks?
I did, but I don't remember what it was about. I even download because I was so impressed that day. It was a meetup for Python, but the guy, he was a PhD actually from Latin America, and he presented something based on Databricks, and I was so impressed that I downloaded something about Databricks. That's all I can say about Databricks.
Sure. Thank you. Anybody else?
Yeah, I've heard of Databricks. I've also heard of data stacks, and I got confused.
Yes. All right. So
I have seen this in the Azure, like we can run the multiple languages. I mean, SQL, Python. Yeah.
Yeah. So I think a lot of people have gotten the flavor of Databricks using like a notebook, maybe. Like they have notebooks that you can use. My introduction was from Databricks was also using their notebooks, but it was also Spark when we were using Spark. So but going back to what Databricks is, so you can think of it as like a one-stop shop for anything data related, right? Where you can do data processing, machine learning, analysis. So data scientists can use it, data engineers can use it, business people can use it. So it's like their goal is to have this platform just for everybody in your organization to be able to use, right? So that is basically their goal. And then around that, they provide you with like some tools, some features that would help with managing all that, right? So features like, maybe just having the data be in one central location, features like, providing you with like tools to do the processing like Python, Spark, SQL, PySpark, to name a few. I'll skip a few things here. So as you can see, they talk a lot about Spark. And I mean, in this talk, we won't get too much into Spark because that itself could be a made up, because Spark is very powerful, but it's also the learning curve could be a little bit high. But yeah. But one of the features that I wanted to talk about that Databricks recently is offering is the concept of Delta Lake, right? And I mean, the first time I heard it, I thought they were talking about still data lake, but no, it's Delta Lake. So basically, what it is it's an open source layer that brings reliability and ACID transaction to data lake. So data lakes, right, did not have the feature of the ACID transaction because of because of one, where the data was stored, but also because of the way even the data was stored, right? In order to have that ACID transaction, the data almost has to be in a, I would say, structured format, right? It needs to be a little bit more structured, right? Hence, most of the database that would offer ACID compliance were your typical relational, I think it's called RDBS, relational database systems. Those ones like the MySQL Server or Postgres, those ones were the one that would give you like ACID, right? But it was kind of unheard of a data lake or something in big data, for example, to give you ACID. So Delta Lake became a very big selling point for Databricks. And I actually, maybe 5 years ago, they did a presentation for us on that. I can't remember any of it today, but they did a presentation on Delta Lake for us. And in the platform too, you can do machine learning. So yeah, it's very powerful. But we'll we'll get into it. As far as key differentiator, for me, I would say the expertise in Spark, because again, they're the people who created Databricks were the people who created Spark. Also, again, that Delta Lake innovation, reliable data lake, and this right here, Unity Catalog. So the Unity Catalog, the way I think about it is, one of the issues that when you have back in the, I'm gonna use again the word back in the day, when folks were using data lakes, right? Not Delta Lake. I'm saying data lakes. There were issues of like data being duplicated, or you would have one version of the data here and then another version somewhere else. So it quickly became a mess to deal with, because people were making copies of certain data, and then after a while you don't know which one is the real one, which one is the single. There was no single point of truth, basically, because of the way data lakes were. You just, for the lack of a better word, throw everything in there, and then from there you start picking what you need, right? However, Unity Catalog, from Databricks point of view, it provides like a centralized access, data discovery, and data lineage across all database workspace. So in essence, from my understanding, it helps you keep a good record of all the data that you have. Okay. You also can provide security around that data in a much easier way, right? Data lineage is also huge because sometimes you want to know where a particular data is used. So one of the things that you struggle with in enterprise is that you could have a team handle, let's say, sales data, right? And they are the owner of that sales data, right? Then one day they decide to tweak something, like change one of the columns or something in that data, even though they're the owners, but they don't realize that another team downstream is using that data to do something with it, right? Because of the way the organization is structured, there's no lineage. So they will change something and then it would mess up like an application downstream, for example. But with data lineage, where your data came from and where your data is being used. So you know upstream and downstream, so that it helps with making sure that anything that you do with that data, you're able to kind of like inform everybody, right? So if we click on the data catalog, right, so this is kind of like the Databricks page. So for those who want to go through it and get more details, but one of the tools that I kind of like is this right here, where you have, and we'll talk about this, right? Meta stores, catalog, schema, table view, volume, and function. So the meta store is kind of like your top level container. We'll create an I'll show you when we do the demo, but I wanted to kind of show you what the hierarchy works. So you have your meta store, your catalog, your schema, and then you have your table at the bottom. Yeah, we'll go back. All right, so I think that's kind of like what I wanted to talk like this quickly. Now I'm gonna go into the actual Databricks account. So if you want to have your own, Databricks offers two versions. They offer like kind of like a community version. I think that one is free, and then they offer the enterprise version. Obviously, in the free version, you're not gonna have all the features available to you. But in the premium version, they give you like $40 for you to use, and then you can use that to kind of play around. So if we go back to my workspace, actually, in order to get to the workspace, like I said, if we go back here and then we'll do Databricks. Again, this is their page. They have a lot of like tools, but if you want to create an account, you can click on this one, and then again, community version, and then this one. So you just basically click on the, I would recommend using the professional one, so you can kind of see all the features, and then eventually you can downgrade to this one. But you just click on this, and then it takes you into like a similar like any platform, put in your email, all that stuff, and then once you go through that, it will basically create your workspace, so it will create your account, which is like kind of like the admin account, and then it will create a workspace as well. So going back to here, this is my account. So you can see here, it shows right here, account. So in the account, I have workspaces. So I have 3 workspaces that are running. And then I have catalogs. One catalog was created automatically by Databricks themselves when you create your workspace, and also I created a meta store as well. So a meta store is a top level container for the Unity catalog that I was talking about. So within that meta store, you have 3-level namespace, and I'll show you what those namespaces look like. And you have other things like usage and user management. Yeah. So definitely the 2 things that I want to talk more about is the workspace, the catalog, and your usage. So let's say I did not have my workspaces running. You can create a workspace right here. You give it a name, and then you pick a region. One thing you should know is that the workspace is actually running. For the version that I'm using, it's actually some things are running in AWS, especially some of the S3 buckets where some of my data files are loaded. But you can pick which region where you want your workspace to run. So for example, you can pick CS Central 1, and if you go into the again, because again, you are dealing with data, right? So you need to know where your data is going to be. So you can pick the default storage if you want to, or if you do the custom one, this is where you can pick whether you want to deploy that storage in AWS S3 buckets, or if you want to be a little bit more involved and configure some other things, right? So for example, this would be for an enterprise. So if a company wants to set up Databricks, I bet they would go with this one, where they would have their own keys. They will figure out what their network looks like, a bunch of other things just for security purposes. But for you using it, just to kind of test it out, learn, I would just go with the automatically with quick start, because what this does, if I go here, let me actually try Ubuntu workspace. Let's do 3. And then I'll pick, yeah, CS Central 1 is fine. If I do continue, so you see, it takes me to my AWS page. And I don't want to go through that because it's gonna create more instances that I don't need to have running right now. But basically what you would do, you would have to have an account with AWS if you are using the AWS storage, where you would basically, I do the signing with root email. So what this would do basically is that when you sign in, when you provide your signing information, again, I have to mention that again, you have to have an AWS account already, right? When you do that and you go through the process, what it's gonna do is that it's going to automatically build the bucket for you, all the security permissions, IAM roles that are needed, basically everything automatically for you, right? I would highly recommend, if you're learning, to do it that way, and then eventually you can do the more of the manual way, which I did first, and then I realized, oh, you could do it that way also, like more automatic. You know what? Let me just try it. I'm sure it's fine. It doesn't hurt. Let's keep for now. Right. So here, it's taking you to create a stack. So in AWS, a stack, you can think of it as like your resource stack. So resource, it's whether it's a server, whether it's a S3 bucket, whether it's a IAM role, it's all gonna be on a stack. But so Databricks is gonna use AWS to create those resources. So CloudFormation is, for those who use Terraform before, CloudFormation is like another example of Terraform. It's a way to build infrastructure programmatically. So you will provide, I already provided a workspace name. You need to provide something else that let me see. Yeah, and then you click on this, and then when you create the stack, it's just gonna do everything. And then when it's done, you just go back to your account, and you should be able to see the workspace running. So I did that, and it created, I have 3 workspaces that are running. Any questions? So again, this is going through the setup, right? This is going through the setup, like a basic setup. For the Metastore, once you have created your workspace, you can now come in and create a Metastore. Metastore, the way I understand Metastore is kind of like some sort of like a location or like a container of like your data, and all the tables, the files, pretty much everything. So that's kind of like I think about a Metastore. And again, you provide the region where you want the Metastore to be, and yeah. So I have my workspace here, so I can now open my workspace. We'll go to it. So I have my workspace called Ubuntu Workspace 2, and it's linked, because when you have a workspace, you have to link it to a Metastore, right? You have to link it to where your data is. So it's linked to this one right here. So I'll open Let me go back. Actually, I need to open the workspace. So this is the workspace. Again, I want to emphasize, you have your account where you do all your configuration. That would be done maybe with an admin from your company. You as a developer is probably not going to deal with the account. You are going to deal with this part right here, which is the actual workspace. Okay. So in the workspace on the left side, you can see you have kind of like this section right here. And I'll go all new friends SQL, obviously. So you have your SQL editor where if you click on it, it's gonna open up like a place where you can query tables or create tables. Sorry, I was playing with this the other day. And right here is kind of like some of the data engineering side of things. So, if you want to ingest data, so for example, here you are in your workspace, but then you want to ingest data, right? So you can either upload a file, or you can use if you have a file in S3 already, you can get it from there. So if you click on that, oh, maybe no, this workspace does not have this one set up, so the other one does. Oh, sorry. Data engineer, interesting. Yeah, but if it's configured and then you have a file there, when you click on this, it's gonna go through basically setting up, creating a table that would basically read a file. But I have that in another workspace. You can even have connectors directly into other things. I haven't tried this yet, but for us, I would say this is the part that's gonna be more useful. Yeah. And you have machine learning, if you want to do more machine learning. So for us, for the presentation, we are going to be more on some of the SQL stuff, and then we'll talk more about the catalog and stuff. So as far as the catalog is concerned, as you can see, you have, where is it? Man. So when you have your catalog here, you have where you can see your data. So for me here, you can see there's some sample data that Databricks provides you with. For example, this one is a famous data set, New York taxi cab data set. You can take a look right here. You can even see the sample data if you want. This is the sample data of that data set. If you go here and then you want to query it directly, you can just click on that, and basically it's gonna query that table for you. So I shouldn't have done select all. I should have put a limit on it. But you can see the job is running at the bottom, right? And this is the data again. If I say like limit 10, it's just gonna pull 10 table. So yeah. So basically that's how, I don't know if you can see intuitively how the platform basically works. It's like a one-stop shop for everything, depending on your job at the company, what you can do. So if you are an analyst or a data engineer, you would mostly live in this area, right? All right, so let me close this and close that. And I wanna so the one quick, I would say, demo that I wanted to show was how to load data, basically read data from S3, the S3 bucket, and read it directly into Databricks. All right. So we have data that is located in S3 in this path right here. It's a data about squirrels. I thought that data was kind of funny. So it's a data about squirrels, and I manually downloaded that data and uploaded it into S3. So if you give me a minute, let me open my AWS real quick, and then so I'm opening it another page. Just give me 1 second. I'm gonna show it to you. Where is it? One second. I have like so many buckets that I'm almost getting lost. It's like which one I use. Actually, I can see it's the store US East one. Okay. There you go. All right. So it's in a bucket, Amazon S3 bucket, and this is my data, squirrels. It's right here. I created it a couple of days ago. Okay. So again, I just created the bucket. And then I uploaded the file in there. Right. Now, one thing that maybe I might be kind of not overlooking, but talking fast about is just because you create a bucket and upload the file, that doesn't mean that your Databricks account can access this file unless you did it that automatic way that I showed you, right? Where you went through and the Databricks itself created the bucket. Because if you manually create the bucket and then you upload the file, you need to actually go through and set up all the roles and permissions so that Databricks can access your file. Otherwise, it won't be able to access it. It's a permission thing. And I have instructions in the notes on how to do that, and even a video on how to do that. It's fairly simple, but it requires. If I go back to, it requires you setting up keys, and actually, it requires you first of all to download a CLI called DB Utils, which is a Databricks utility in your local machine, and then to add those keys into a scope. And that way, when you want to access those keys in like a notebook like this, it's able to do that. And those keys are like your AWS keys. So when you go to AWS, for example, like if I go here and then I go here, if you do security credentials, if you click on that and then you come to, you're not going to see the keys anyways. You can only see the access key, but you can't see the actual secret key. So you have to come here, and then because I have two already created, I can't. But if I had one deleted, you could do create access key. It will create an access key for you, which you would need to copy. So this is the access key. And then there's a secret key that it will show you that you also need to copy. Right? Actually, instead of just talking, let me do it. Let me delete this. I don't need this. Action. Delete. So I haven't used this in a while, so I can just delete it, and then I'll try to. Maybe it won't work. Let's see. Yeah. So when you come here and then you do create access key, then you do understand, then you create it. I don't want to show you my keys right now because I'm doing, but basically you do it that way. So you do I understand, and you click. You have to, again, I mentioned, you copy the access key and the secret key because that is needed when you create the scope and then store those keys so that Databricks can use them to access your S3 bucket. Does that make sense? And again, that's kind of like one of those data engineering, I wouldn't even say software engineering little skills that one has to learn how to do. Because a lot of these things, the documentation is there for you to follow, but you will run into hiccups. Things change, they change things sometimes in the platform, the documentation are not changed at the same time. So you will run into issues, and the skill is to be able to go through those issues, figure it out, and then get it working. Yeah. But yeah, so I have the keys in there, I have everything. So then, as I mentioned, the file is located in S3. So if I run these, one thing again is that I have, because this is a notebook, right? So I have a like a instance running for my for these cells to work. All right. So I think I can just, all this is already set up. So if I come here, I can run this. So what this is doing basically, right? It's using Spark again, as I mentioned to you guys. It's using Spark to read that CSV that is located in S3. Again, this is in a completely different machine. S3 is in another machine, right? So it's finding a way to access S3, read this file, infer the schema, and then get the headers from that file, right? And then this is the data that it basically shows. Oh, sorry, yeah, and then you have to run this. It puts it in a data frame, which is a kind of like a structure, kind of like a Excel type structure, and then you can display it. So this is what the files look like. So you have the area name, park name. Essentially, what this file is the sightings of squirrels. So where in New York people are seeing squirrels? So Upper Manhattan, squirrel ID. That's funny. The fur, so the color of the fur, so gray. Highlight of the fur, some notes. Where did they see the squirrel? Is it the ground plane? Is it on a tree above ground? And some other stuff, right? For example, what is the squirrel doing? And in interaction with humans, did they run from you, or were they indifferent, right? Anyways, so but the point here is you are able to use like kind of like Spark code to read the file and then display the file. And you can start doing some fun things with it, right? You can start like running it and seeing, for example, how many of them had cinnamon color fur. Obviously gray is the biggest one because a lot of squirrels are gray. So what this code is doing is taking that data frame that we had at the top here, and it's grouping by the fur color, which is the column. It's doing an aggregation on that column, and then it's giving a new name, which is squirrel count. And then when that's done, it puts it into this, I would say, variable, and then you show it. So for those who have done SQL before, what does that look like? Doesn't that look like SQL almost? Group by is kind of like a SQL term. Count is kind of like a SQL term, So that's why I keep saying that, SQL is like something where if you learn that first, everything else that deals with data, it would pretty much, because it uses anything that tries to manipulate data would kind of have that SQL feel. So people are familiar with the syntax, right? Because SQL makes sense. I'll skip this one. Another example is kind of like, basically this is data. I'm doing some data analysis on that file. Again, that file is located in S3, and I'm just kind of like doing some analysis, right? Again, I'm doing some group by, I'm doing some aggregation, I'm renaming columns. So basically, hey Ben, go ahead.
Question, is it using the Pandas API?
No, not this one.
Okay. That's what it reminds me of.
It does, right? Yeah, Panda PD, right? Yeah. Let me. No, I don't think. I'm not sure. I don't think it uses the Panda yet. No. Trying to see like the data frame. Actually, hold on. It is use the Panda data frame. Yes, it is. I got confused with something else. Yeah, it's a data frame. Yeah. Yep. It does. Yep. So basically, Spark, like Spark code itself, like core Spark, you could wrap course. So okay, let me step again. Right now, we are writing PySpark. It's a Python wrapper on Spark, right? So you see it's Python code, but in reality, it's using Spark. So PySpark is actually fairly popular. So it's a simpler syntax, basically. Yeah. Let me see. Yeah, so basically that's kind of wanted to show you is that the notebook helps you do some quick analysis here and there. Yeah. So that is this part right here. The highlight that I wanted to make again is that if you want to read anything in S3, you kind of have to have your security set up. I'm gonna go to a different workspace. And to do that, I can just change it here. And I'm going to go to this one. And for this one, I want to show you a table. What is it? Catalog. Yeah, catalog. So in this one, I have a file, another data set that I loaded. And again, these are kind of like data set that you can get from Databricks, but I don't use that. The one that I'm using is this one, 10 million people. So that one I actually like uploaded into a volume. So volume is another storage structure that is provided by Databricks. I'm still learning on how it works specifically, but the way I understand is that the volume still sort of uses AWS when it wants to do when it wants to track changes in your data, right? But right here, I created a volume, a workspace, a schema, and then the volume right here, and I uploaded that file. This file is a record of 10 million people. You can think of it as almost like a census data. So it's just data about people. It's fictitious. It's not real. It's actually fictitious data. So that's where my file is located. Now, if I want to play with the file or do some queries with the file, then I can go into a notebook. So that notebook is this one, the Delta Lake notebook. So the Delta Lake notebook, the point that I want to, and this is kind of like towards the last part of the presentation, is talking about the Delta Lake, right? And one of the feature of the Delta Lake, as I mentioned to you, is the fact that you can all the transaction, all the things you do with that data has history, right? But we'll get to that towards the bottom of the notebook. But for sure, before you are able to kind of create that Delta Lake, this is kind of like another way of doing it. So the file is actually loaded into a volume, I think I showed you that a little earlier. So this is the location of that file. This right here, what I'm doing is I am essentially creating a schema, and then I'm saying when you read that file, create these columns, and then provide the data type. So for those who have done SQL, it's similar, right? Create table, and then you provide the column names, and then you provide the field type. So it's similar to that, but these are just kind of like Spark notations. And again, we put it in a data frame, and if we want to describe the data, actually, I can run this again. So our data set describe is just kind of like a simple tool to help you, a simple code or syntax to help you kind of see what the data looks like. I have to run this. But yeah, it gives you kind of like an idea what the data looks like. It errored out because I need to run this first because the data frame does not exist. Oh, one cool thing that I've noticed about Databricks that I've been using a lot is that if you have an error like this, you can say this is AI. This is it's using AI. So if you say diagnose error, so on the right side here, it's gonna say, hey, the error indicates that the variable df is not defined. You need to ensure that it's probably defined. Okay, so that says that it's not defined. So I know I've done this. I've used notebooks before, so I know, oh, it probably means that this cell needs to be ran. So I go back and then I just run it. Obviously, the AI does not know that it's because the cell has not been ran, but it kind of gives you an idea that the reason why it's failing is because the data frame has not been defined. So you can close this, and then if I run this, it should work. So this is it's actually doing a Spark job in the background. So it took 4 seconds. Yeah. So this is kind of like a statistics about the data. Now, any questions before I continue? Okay. Now we're gonna create an actual table. So we're gonna import a delta table. We're gonna call this code right here create if not exist. We're gonna provide a table name, and this is the schema. Or so we're gonna create it in the workspace default, and then call it 10 million people. So this is, you can think of it as like a folder structure. So folder, some subfolder, and then file name. And then you provide the structure, and then we execute. So the table already exists, but I think I can run this again because create if not exist, because if it doesn't, if it exists, it should not create it again. So we'll see. If it bombs, it bombs. Right, so it ran. So it will only create it if it doesn't exist. Now that the table is there, we're going to now load the table. Remember, when we create the table, it's empty, right? Now we have to load the table. So what this is going to do, again, remember we have that data frame. We're going to write to this table, and then we call to create or replace. So if it doesn't exist, it will load it. If it's empty, it's going to load it, or it will replace it, the data that's in there. So we'll replace. So that replaced the data in there. Now we're going to do an upsert operation. So what this is doing, what an upsert is, it's basically going to load some it's going to load some data into the, actually it's right here, it's going to load some data into the table if it's able to find the same data based on a key, right? It will update that data. So for example, if it's, when it's loading, if it finds a key, the same key, and it matches on this record, it's just gonna update that record with whatever new information you're bringing in. But if you can't find that row is the same data, it just adds the data. So that's what an upsert does. So for the upsert operation, this is the data that we're going to load, right? We are going to kind of like do it in a couple of steps. We're gonna create like a temporary table with this same schema, and create like a view from it. It's a temporary view, and this is kind of like the operation to do that upsert, right? So it's gonna use our table. Then when you do the basically we're going to merge, right, that upsert. So when match, update all. So if it matches a row, update that entire row. So when not match, insert, and then execute. So we can run that. That's always a good sign when you can see this. So these are Spark jobs actually running. I keep saying like Spark jobs. So that's done. And then we can now kind of take a look and see, okay, the row that we inserted, like, was it inserted? Yeah, it should be there because I tested it yesterday. So we inserted, if you remember, if you go back up real quick here, you have Billy, Elias, Joshua, John, Mary, Jane. So Elias, Billy, Joshua, Mary, Jane. So the records are in there because we're querying that table now. Yeah. So I mean, basically, what this is doing, for those who know, basically what this is doing, it's saying query this table, filter on ID that are greater than equal to this, and then show it. So you have a couple of ways of updating writing to a table. You can append, which means that you are adding like a new row, or you can override. Override means that you're replacing it, basically, right? So these are a couple of ways you can basically update a table. And knowing the difference between the two is very important, because sometimes you want to append data into a table, sometimes you want to override, and these two are very different. You can update a table, which a way to do that is this way, but you have two ways of doing it. You have this kind of like SQL style, and this is kind of like the Spark SQL style. So the SQL style, obviously we create the table again, so the Delta table for that. So you load the table, and then you say, hey, I want to update that table, right? You call that function, and then you say condition when the column gender is F, then I want to set that column, all the values in that column, to actually female. Basically, it's gonna filter if in your table you had 30 females, so basically 30 records that I have F in it. It's gonna pull those records, those 30 records, and change the F to female. So that's what an update. This is what this is doing. Yeah, similar to this, right? So this is just a different way of doing it. So you have column gender. If it's equal to male, then set that column or everything in that column to a male. So basically you're changing it from the small m to MALE. So that's an update operation. You can delete also, you know, It's basically like this. Birthdays that are less than 1995, January 1st, delete. So if you want to purge a table, for example, that would be an operation you can use to do. Obviously, I would not go right away and do it on the main table. I would take a copy. Typically, like, when you're doing things like that, you take a copy of the table first, then you do the operation on the table, and then if you're satisfied with that remaining then you could keep the copy for maybe some time, because you never know, right? You could do some mistakes or do something on that table. At least you have a copy you can reinstate or bring that data back. So it's all in data database person or a data engineering person. You always take a copy before you do any sort of like irreversible operation. All right. So the interesting thing now about Delta Lake is the fact that anytime you do something on that table that affects that table, that change something on that table, it actually creates a history of that table, right? So, I in regular databases, and please keep me honest, I don't think if you make an operation on a table, unless you've taken a copy of that table, that you can go back to a previous version of that same table, if that makes sense, right? Especially not in the context of files or a data lake kind of situation or data warehouse kind of situation. So the nice thing that Delta Lake is bringing into Databricks or into in the data warehouse world is the concept of having the history of your table. So in order to do that, right, you can call this function here on that Delta Lake and check the history. And you will see all the operation that I've done on that table. So for example, on the 25th, today, I did a merge operation, if those who remember. This morning, I also created a table, I did something else on that table. So it kept the history, right? Yesterday, I was doing prepping for this. I did a bunch of stuff. I deleted some data, I updated some data. So you can see I have the history. I even have the first history of that table when I created it. That was like, last night or something, right? So this is very useful, because what this means is that if you want to, let's say, you did something and you want to go back to previous version of that table, you can go and just kind of say, hey, can I query, this data and query this information. So I want either when version is equal to 0, basically we mean the first version, so you can see right here, or this timestamp. And the timestamp, you get it literally just from here. So I can do it this way. Let me copy the timestamp from today, and then we'll try that. So if I copy this, oh, of course, you can do a presentation without having errors. What did I do? So I like this. I missed out. So you see how it's pretty nice? The assistant is helping me, right? So I can say accept and run. There you go. All right. So I got both, right? This is actually really neat. I got the first version, which was the 24th, and I got the one that we did today. And again, with this, and you can see what you did on the table, the operation that you did on the table, who did that operation, what kind of operation it was, especially the person who did it. Yeah. So I keep going back and then stressing that point is that once you have that ability, right, it helps a lot in traceability and seeing, okay, who's done something on our table, who's done something on our files. I made a mistake on this operation. Let me revert back. Those kind of things, right? in a whole lot more, but at least I wanted to kind of give you a flavor as to what you can do with Databricks, some of the neat features that it has. There's a lot of things that maybe I couldn't present because either it would just take a lot more time, or I think it would be beneficial to actually go through that, because that is actually where the learning happens, right? So in order to get to this point, in order to get your data in a place where you can query it, I doubt you will go through and then like it would go be perfect the first time. You'll probably run into some errors that you need to fix, but there are resources out there that you can definitely use to fix all these issues. In my link, I also provided all these links in the gist. But yeah, and again, if I go back here and I show you where that file was located. So for those who remember, so it was workspace, default, and then 10 million people, right? So basically workspace dot default dot 10 million people. And the table itself, I think it's what is the table? Yeah, I think the table is there. Yeah. So any questions on this? Go ahead.
Yeah, okay. So maybe my first question is, I mean, maybe I'll start with a comment. Earlier, you were asking about the history of the table. Like I've seen that done, but there's a nuance. So first, it was a manual process. I mean, somebody will need to, for regular databases, like the DBA or whoever is in charge of the database will have to create a special purpose table in the schema, and we'll have to adjust maybe the ORM with some sort of callback. So that whenever there's a CRUD operation like insert, update, or anything like that, it will be recorded into that history table, right? But the data itself, if any destructive actions were taken, that data will be gone.
Yes.
So yeah. But,
yes.
But if I fast forward to like some of the newer databases that are, that are becoming more popular, I'm thinking about databases like, let's say Datomic or XTDB. Like those things, those things are they designed it in the way that they don't really take destructive actions on the data regarding of the operations. They just record the fact. So for example, earlier you were talking about the squirrels, right? Let's say you want to change the fur color to yellow, right? When you change it to yellow, is as of right now, today's date and time, right? But you can still query the fur of the squirrel as of yesterday, and still say that it was still a different color yesterday or the week before, right? So that's how they record the CRUD operations. There's a time component attached to it.
Yep.
So that you can do some time travel if you need to.
Yep.
Yep.
And I think I mean there a lot of databases or database vendors have realized that destructive operations can definitely be a pain. I remember definitely going through migrations, database migrations, and sweating bullets because if you make a copy of the data or you don't make a copy of the data and something happened or dropping a table, I mean the data is gone. You know what I mean? It's just gone, right? Like there's no way, to restore anything. Like, I mean, there's usually a way, but it's just a pain, right? So with these kind of like newer ways of keeping history, it's definitely less
Yep.
intense, I guess, if it lack of a better word.
Yep. It's a much better default, and it actually maps pretty well to, to real life, right?
Yes, yes.
Because you can look at facts as of last year, as of 2 years ago, and so on and so on. It's not because you change something today that it changes the past. So
yes, exactly. Yep. Yeah. And as far as the Delta Lake is concerned, what you have to remember, one thing is that the way, from my little bit of reading, the way it keeps that history, it actually creates a bunch of small files of that data. So, ultimately, a data cleanup needs to happen at some point. Let me pull up that information real quick here. Give me 1 second. So it actually creates like snapshots. So basically, at some point, cleaning up that data would be needed, especially as to in the future you don't need all these like small remnants of files, because that is, again, I'm saying, like, from reading and understanding how they actually do the Delta Lake is doing small copies of the same data somewhere, but eventually you won't need older versions, right? So you otherwise operations on those files, you will suffer in terms of performance. So yeah, remove unused data file with vacuum. So that's another operations that is available. Yeah, but yeah, that's kind of like what I want to talk about today. So really concise talk today, but my thought on Databricks is it's a very powerful tool. A lot of people really like Databricks. And you can actually be certified as a Databricks developer. They've had certifications, I would say, for at least 10 years now, if not more. Like I said, they have a relationship with Azure, Microsoft, and a little bit of AWS as well. Also, as I mentioned, their main competitor is Snowflake. But Databricks is still technically privately owned. They're not on the stock market yet. And yeah, I think they're still growing. But yeah, I would say the only thing that I noticed is that it could be a little bit expensive, because they gave me a $40 credit, and somehow I blew through that. So I was like, that's kind of expensive, But I also forgot, and I kept one of my machine running overnight, so that could be the issue too. So yeah.
Plus from the names of the table, right? I see people 10 million, so I'm assuming it's 10 million records.
Yes.
Okay. So behind the scenes, that might be using a lot of resources to do operations.
Yeah, it definitely is, but I still think that it's still a little bit expensive, because I've used BigQuery, but BigQuery is just a warehouse, right? It's not like a platform like this, right? But it's definitely much cheaper. But yeah.
So maybe I have another question for you. I've seen that you use the PySpark, and some of the API looked like pandas, but I know that PySpark is derived from Apache Spark, which is Scala. So can you maybe comment on the relationship between, I don't know, PySpark and maybe the Scala runtime, or do we need Scala at all, or is it preferable to Python?
No, so Scala, you can do it with Scala, and a lot of people actually prefer Scala, because when you write Scala directly, it's able to you have I have personally not used Scala before, and I know that in terms of performance and instead of compiling and stuff, people prefer Scala, and you get apparently you get more function. It's even closer to the Spark engine than all the other wrappers. So Scala for sure, if you're able to use Scala to write your functions, is good. I think it's even preferable. However, PySpark PySpark was introduced because for those who don't want to necessarily learn Scala, PySpark is much, if you come from Python, it's simpler to grasp, right? And you're still able to do, most of the things with it, writing your pipelines and things like that with it. So personally, my learning of Databricks or my learning of this whole thing was through PySpark early on. And I've worked in some places where they have offered they've done more of the PySpark than the Scala, but I would say it's only maybe 1 or 2 times what I've seen someone actually using Scala, but yeah, so that's kind of my thought on it.
Yeah, I think what's for sure is that even with the Python interface, which is PySpark, all it does is to turn around and send comments to to the engine, which is I think written in Scala, if I'm not mistaken.
Exactly. Yep. So it's just a wrapper.
Right.
Yep. Just a wrapper. So I mean, another comment about Databricks is, if let's say you want to become a data engineer, again, I would not go straight and learn Databricks because here you're learning a platform. You can leverage Databricks to learn some of the SQL and even like maybe learning how to deal with cloud, with like figuring out like S3 buckets and things like that. However, if you're really new to this, my recommendation is certainly to learn SQL first, which means that go into the basics of like maybe setting up spinning up a database, loading data into it, querying the data, being comfortable with thank you, Sai. Yeah, and hopefully we'll see you in 2 weeks again. And then learning it that way. And then because Databricks is more a platform, and going straight to a platform, yes, it's good, but then you're stuck on the platform. You are defined by the platform, and that I don't think you want that. You want to be more of a learning the standards, and then whatever platform they throw at you, it's just a matter of reading the documentation and then learning how to use it. It's simple as that. Yeah. I don't know, Ben, if you want to comment. I knew you were gonna comment. Go ahead. We're talking about this.
For me, it's always my preference, right?
Yes.
Anytime I see a tool, whatever it is, my first instinct is, can I run it on my machine, on my own server? You know what I mean? Because every time I see that it's a cloud only like solution, it's almost as if I feel trapped, in the sense that not only I always have to go to that provider, but also my skills are become specific to that one provider. So whatever I learn, I don't have any guarantee that I'll be able to leverage it somewhere else. Whereas if it's a tool that I can run anywhere, including my own machine and my own laptop and my own like server, then my skills become portable. I can do it with one provider if there is a need, or I can take it somewhere else. So yeah.
100%.
Yeah, because that's for sure. When it comes to companies and finding a job and all that, companies have their own preferences. So if you learn something that is AWS specific, and the company is using Azure, then I mean you won't be able to leverage your AWS skills to do Azure, because things are a little bit different. Even even when running VMs, like I know for personal projects, people use things like Ubuntu and I don't know what else is there, like Alpine and so on and so on. But in some companies, they will default to, I don't know, something like Red Hat, because it has been certified in terms of security and stuff like that. So learning Linux and Red Hat, for example, it's a portable skill, right? And so,
yeah. Any other comments, questions? At least like I hope you've learned something about Databricks. You have a better understanding about the tool. Quiet today. All right.
Yeah, no, you definitely simplified it, because I heard it first time I heard, I didn't even click on it. I was like, that would be too complicated. So thanks for making it simple. As usual. Thanks.
Yep, no problem at all.
Question.
Yes.
What do you and Benjamin want us to focus on? What should we be? Data science? Data engineer? DevOps? Which should we learn? My head is spinning right now.
That's a good question. I mean, me personally, and I think Ben and I maybe share the same, because him and I have talked about it many times, right? I think learning the standards is the way to go first. So by standards, and that's a term that we have been coined out literally last week, is if you're gonna go in data, right, it's gonna be SQL, right? If it's gonna be SQL, it's gonna be picking a database and learning how to work with that database. So it's standard. If you're gonna do software engineering, learning the basics of software engineering, not necessarily trying to learn like a framework, like jumping, for example, to what is one framework that Node.js is a framework, I think. Not necessarily jumping to a framework, but learning the basics of software engineering. Data science, you gotta go into the basics, which is like the math behind it, like the statistics, the probability, all the things that takes you to become like a true data scientist. Because once you know those, then it becomes easier to be, for the lack of a better word, portable. By portable, I mean if they throw you into a DevOps kind of situation, right? I'm not talking about like they're taking you and putting you and becoming like an architected DevOps. No, but like either entry level or mid level DevOps person, you having the standards. Yes, your learning curve might be a little bit steep, but it's not going to be as bad as someone who has never seen DevOps, for example, right? Because you know how computers work. You have an idea of like what DevOps entails, meaning, oh, I'm trying to make sure that this build, is get done. I know how security work. Maybe I'm using the clouds, those kind of things, right? So it's hard to say what you should learn, because if you learn one thing, for example, if you jump into data science today, like with all the AI, that is going on, like I've even tried to do like a search on like data science jobs, and I don't, those titles, I don't see them as much anymore. A lot of it now is like AI engineer, but to be an AI engineer, you still have to know a little bit of like data science. You still have to know perhaps some things about the new stuff like LLMs. You still have to know software engineering, right? But if you have the standards, if you have the basics, right, then all of that is not as intimidating anymore, right? So that's kind of like, I don't know if that helps in your answer, in your question.
Yes.
Yeah, maybe I can jump in and
Yes.
answer it a different way. Like to me, if I look at the everything that's happening in tech right now. And then I want to focus on learning the fundamentals and standards. I will pick a programming language. I don't know, you can pick one, Python or JavaScript, in anything. And once you know how to use that programming language, now you have to learn at least the protocol of the web. You have to learn what is HTTP, what's happening in an HTTP exchange. So you familiarize yourself with the HTTP protocol, and then you can think of things like, okay, how do I save data so that can be retrieved later for, I don't know, for performing a certain function, right? That's when you will start to look at your databases, like your NSQL. So in that case, you can pick a simple database, right? Maybe pick SQLite that doesn't require a separate server, or maybe pick PostgreSQL, right? And from that same language, you get to interact with that database to understand how it works, right? And then that's how you build it. Because when you look at all of the tools that exist in the wider ecosystem, like for example, what Aziz presented today, those are specializations of a certain area in the way you interact from the programming language, and how the data is persisted or processed. It's just a specialization, so more tools were added around that simple process from the beginning. You know what I mean? And then always from your programming language of choice, you can start to learn also some algorithms. So there's a whole bunch of algorithms. There are algorithms that are used in the context of data science. Basically some rules that let you retrieve some data or understand some data and make predictions. There are algorithms that let you implement systems that are performant, and so on and so on. So from when you approach it from that perspective, it's as if there are not that many, the tools are not that different one from the other, because you start by learning the fundamentals, and then you can see those same fundamentals in all of the other tools.
Yes.
That's how, for example, I had a question earlier about pandas. I was looking at the code that Aziz was presenting, and the first thought was, oh, I've seen this code before. It had nothing to do with Databricks. It was more when I was learning about algorithms, we started using tools like pandas to traverse data frames, right? Yep. And it looked exactly the same. So,
yeah. So, I mean, as I mentioned earlier, we did some talks about SQL last time. Not last time. Earlier, like when we even first started these meetups. I mean, I could go back again and redo. I mean, obviously updating it a little bit, like some of the SQL stuff, like really from a beginner standard view, and have that maybe as our next topic. Because for SQL, for data, again, I keep stressing that out, like data for sure, SQL is going to be your first thing to start with. So, I can maybe look into maybe getting SQLite, how to download SQLite, how to, set it up and then put some data in it and do a talk on that. However, that's the caveat to that is me doing it and showing it. You will only learn if you also go and do it. That's the only way. There's no shortcuts. Nothing is gonna. Yeah, you gotta do it too. So.
Yeah, but like maybe one thing we could do also, Aziz, when we make the presentations. I think I started last time with the series on Go and the APIs. I try to like stick to the standard library as much as possible. So that there's no really like an extra library to go and install and all that. Basically, having the language itself, a lot can be done.
Yep.
And I know for Python, right away you will have access to SQLite. You have access to a simple HTTP server and so on and so on.
Yep.
So just having Python itself lets you do a lot. So.
Yes.
Okay.
Any thoughts on that talk? Because that, for those who have seen it already, maybe it could be a refresher, but yeah, and then we can go back to some, because we did a lot of LLMs in the last year and a half. We haven't done cloud and data for some time now, so that could be another go at it. So, but really going from the basics, I guess, is what I'm trying to say. Any comments? Quiet bunch. All right. Well, that's really it for me today. I guess it's only us now. Yeah. Yeah. We'll
noisy background, so I can talk. But it was very informative. I said like it was very informative. Yeah, but I got a noisy background.
Oh yeah, that's all right. No problem.